Welcome back, everyone. Time for another stream. We'll continue working on the CommonFS, but just like in the previous stream, maybe we can take a peek at some of the tutorials just to warm up a little bit. While our brains are fresh, we can, learn a little bit. And also, remember to like, subscribe, follow on Twitch, comment with questions, suggestions. Even after the stream is done, I'll be always happy to answer. And I don't know, maybe this stream will be chopped up into some smaller, more digestible pieces at some point, although at this point I am not sure yet, because not sure if that will make for any decent content. So let's open up some tutorials. Let's just duplicate that, and this will be our tutorial. Let me switch to the screen, and there we go. So we started last stream a little bit of the first part of the first part of the official tutorial. Okay. We looked a little bit through the first program. Where did we finish at? I don't remember where. String and character literals. Where did we finish? We looked through the numbers. Yep, constants. The let statement. All of that we already know. The if statement looks okay. Case statement looks nothing special. They just point out that we can have two or more. We can use parse integer. And cases can have even multiple range operators. Multiple ranges. While statement, for statement with a count up. Since counting up occurs so often in programs, it also has the dot iterator, the range one. Exactly. And we have a count down. We learned about all that already. And then we have, when we add a greater, lesser than whatever symbol, that means that 10 won't be included, so it'll be from 0 to 9. Yep. And we can do also the same thing with the hat operator or whatever. That means this will be last element. Okay, we know a little bit about items and m items. We provide immutable and mutable elements, and the same with pairs and m pairs. We need to remember about those being there, because this might be very interesting. Scopes and block statements. Okay. We can label them. We have break, continue, when, indentation. Did we already go through all that? I don't remember. I totally don't remember how much we went through last stream. It's like blank. Oh wow. We have everything okay here with the procedures. Yes. Okay. The result variable, we learned all that. And the result variable is also already initialized with the type's default value. Note that referential data types will be nil at the start of the procedure. Exactly. If we have references, they'll be just nil. Like empty pointers. Okay. And a procedure that does not have any return statement and does not use special result variable returns the value of its last expression. I guess this is important to remember, that only if there are absolutely no return statements anywhere else, this will work. So if you would have one branch of if that has that, and the other one has return, only the one with return will actually return something. I want to test that, because this sounds like fun. Let's get back to our code, and do we have something for testing? Didn't I set something up in our task or settings? Module.nym usage. Let's create quick module.nym, or like quick fun.nym, okay? We'll just shove this here, and we do just call hello world, okay? When I save it, and we need to discard the return value, so echo hello world, okay? If we're gonna try to run it, just get hello world, okay? Which is decent. So if we do that, it's, come on, 2 spaces. And then using spaces too. So if we'll do if true, right? If true, will be hello world. Else will be goodbye world. Perfect. So if we'll run that, it still works. But what if we're gonna put return here? We save it and we run it. Okay, so they lied. It'll still work. What if here I'm gonna say that result is goodbye world? Oh, now the compiler is unhappy. Hey, you have this thing. So if we'll do return. Oh, look at that. So, ooh, that is super handy. Does it still work? Yes, it works. So look at that. This just revealed something. So if we have no return statement, like let's say for if this was false, it will go to else, whatever, right? The result will be set. So let's do if, let's do let branch is false, okay? And we do if branch. We save it and we run it. So now this is goodbye world, but there was no return. We set the result to that value, so it did something. While here, if we had it as true and we run it, we have it returned as well. So something tells me that, let's say sometimes you have a procedure that needs to work on, you know, something more complex. It builds some kind of response, okay? Or whatever. So you would often have a situation where you would have, you're utilizing that result is there. You said, let's say result dot a is this, and then you do some calculations, right? And then you continue with it. So result is, you know, dot b is whatever, something else. And you have more calculation, and so on and so on and so on. And at the end, you know, you do this or see, I don't know. Yeah, that's fine. Something. You have those things. So at the end of your proc, you basically have an object that's fully constructed. And, you know, that result maybe was some kind of response or something. I don't know. Whatever. Something more complex than a simple string, of course. So what if you have a situation like that, and you need to handle those situations where something isn't right with data, and in your use case, you don't really care about, you don't need to raise an exception or something. It's just, you know, edge case that needs to be handled, that, you know, suddenly you're returning some different object. So you could have somewhere in your code like if, you know, something's wrong, you just do return and some other response, right? So that means that you could keep building that. You have it clear, nothing changes anywhere. And you use those return statements only for those little short, like, oh, you know what? I need to return something else after all. I like this kind of usage. That sounds like, you know, decent use case. So hey, we already learned something. Let's look a bit more through it. We have those parameters, basically things that we pass in here. So are immutable, unless we give them var. And shadowing the parameter name is possible, and actually an idiom. So we have n printed integer. So we set another var printed. So we shadow this one here with just a proper processed value. Okay, makes sense. I'd say it's used pretty often. I would use something like that pretty often, and then we just go over it. Cool. If the procedure needs to modify the argument for the color, var is used. Yes, so if we need to modify the remainder, we just define var integer, and therefore we can change it here. Okay. So that makes sense. Discard statement, of course, we can discard something. This way compiler won't be upset about us. And the return value can be ignored implicitly if the caller proc iterator has been declared with the discardable pragma. Okay, so if we have this that returns something like integer, and we still want to just do stuff with it, but by default not need to write discard everywhere, because let's say that return value is like optional, we can just put in discardable. So I'm gonna use it right now. Let's go to our code for the CommonFS. Okay. And I would like the create file, okay, that returns the file to actually be discardable. Because we won't always need to have this whole, you know, require this to be returned. So yeah, return value could be discardable. Sure, I just want to create a file. I don't want to handle it. So that's great. So we've got that. Although should we? Should we or should we not? Do we want explicitly say that, hey, this is discardable, you know, explicitly say discard create file? Nah, because the operation did this thing. The return value is like, you know, an extra. Oh, it's nice that I got a file back so I can continue operations on it. So yeah, let's make it optional as in discardable. Great. I like that there's an option for that. Name arguments. Often procedures, a procedure has many parameters and it's not clear which order the parameter appear. This is especially true to procedures that construct a complex data type. Therefore, the arguments to a procedure can be named so that it is clear which argument belongs to which parameter. So if we create, you know, have a proc like create window, which, you know, takes X, Y, width, height, titles, and if it should be shown or whatever. Classic example, I'd say. We can actually specify, hey, show equals true, title is this, and we're using equals in here. Okay. Good to know, because many languages will be just colon. All right. I like it, and that could be probably, now that we use named arguments to call the create window, The argument order does not matter anymore. Mixing named arguments with order arguments is also possible. Not very readable. Yeah, we have those two, and then we have just title and height and width, and then randomly true at the end. What the hell? Is it gonna figure it out? I guess so, because we got those two numbers, right? X and Y. Then we have width defined. We have height defined. We have title defined. The only thing left is show, which is Boolean, and we just give it here. Wow, that's actually possible, but real ugly. Although in some cases maybe possible. I don't know. This will be nice when combined with something like default values. Exactly. So our create window could have a bunch of default values defined, right? Like sensible default values. So in our create window, we only specify the ones that we actually want to modify. Like, well, we just care only about title, height, and width. Can be a default space, and by default is being shown so that we don't have to specify those. Perfect. I don't remember what language now, but I remember there being a language that just didn't have default values. It's like, seriously? This is so handy. Like function/procedure overloading and default values are like must-haves for me. Okay. Oh, and also type is inferred. Also, like right in the declaration, title is unknown. Okay, so we don't need to specify that, oh, this is a string, or this is a Boolean, or these are integers. It just figured it out for you. So again, perfect. There we go. Overloaded procedures. NIM provides the ability to overload procedures, which is awesome. So, and without any overloaded keys or anything, it just, hey, we'll figure it out. So we have a proc to string that takes an X and returns a string. Then we have another to string that takes a Boolean and returns a string. So depending if we're gonna call it with integer or with Boolean, it will figure out which one to call. Awesome. Note that the toString is usually the $sign operator in NIM. Yeah. So yeah, the compiler chooses the most appropriate proc for the toString calls. How this overloading resolution algorithm works exactly is not discussed here. See the manual for details. Ambiguous calls are reported as errors. Okay, so it won't secretly choose one for you. It will just complain like, hey, something's ambiguous here. Please, be more specific. Then we have our fun with operators. The NIM standard library makes heavy use of overloading. One reason for this is that each operator, like plus, is just an overloaded proc. The parser lets you use operators in infix notation, as in A operator B, or prefix notation, operator A. An infix operator always receives 2 arguments. A prefix operator always 1. Postfix operators are not possible because this would be ambiguous. Yeah, so if we would have the operator like A, whatever, something, and then the operator, what would this mean? Is it, does it mean A operator and something B here, or this? Here, because we don't have postfix, so there's no combination like this. That can mean only that we'll have this as one thing, and then it's A operator, this thing, right? Let's see. A operator and this thing. Perfect. Apart from a few built-in keyword operators, such as and or not, operators always consist of these characters. Now we have a bunch of characters, and I think there's actually a little bit more that we can build stuff with. And the crazy part is that depending on some rules, like period, or I think it was question mark or exclamation mark, some of those, they have some rules which takes precedence over which, a little bit convoluted, but still, I guess you could easily overcome this. User-defined operators are allowed. Nothing stops you from defining your own, whatever that will be, operator, but doing so may reduce readability. Exactly. To define your operator, enclose the operator in backticks. So it's just a normal proc. You just have the name of the operator in those backticks, and the rest is normal. In this case, it will be the prefix operator because it has only one value, right? Perfect. Okay. And the backtick notation can also be used to call an operator just like any other procedure. Oh, okay. So if, and we take equals operator, which is, comparison, we literally call it in parentheses the left argument and the right argument. Oh, we can even call it this, add 3 and 4. Oh, that's funny. Very hard to read, but possible. I guess I can see this being possible if you want to generate some code, maybe. But again, sometimes macros will be more useful here. And let's just skim over maybe those two next things. Forward declarations. Every variable, procedure, etc. needs to be declared before it can be used. The reason for this is that it is non-trivial to avoid this need in a language that supports metaprogramming as extensively as NIM does. However, this cannot be done for mutually recursive procedures. So we have forward declaration, right? We just say that there is a proc even that takes this argument and returns that type. And we don't have equals what, right? This is just a definition or declaration, right? And then later, we have something like odd, which basically uses that even, right? Is this or even? So makes sure we don't run into negative recursion, whatever this is. We don't care about that, okay? And then we actually, after this whole thing, we actually define even. That is using the odd. So they both refer to each other, but they can do that because, we declared the even earlier just without the actual implementation. Perfect. Easy. Something like in C++ and I believe many other languages. Here, odd depends on even and vice versa. Thus, even needs to be introduced to the compiler before it is completely defined. The syntax for such forward declaration is simple. Just omit the equals and the procedure's body. The assert just adds border conditions and will be covered later in modules section. Alrighty. Sure. Later versions of the language will weaken the requirements for forward declarations. That would be awesome. I like languages that allow you to just, define things, move them around, not worry about it. Let's say I'm doing stuff in C#, I can group things however I want. Doesn't matter when they are defined. So yeah, this would be nice to have a little bit more like that in NIM, but yeah, because you can make all the macros and all the crazy things, it's a little bit difficult to implement, I guess. It could stabilize the language a little bit or probably introduce lots of weird stuff. Okay, so let's just go through funcks and methods. As mentioned in the introduction, NIM differentiates between procedures, functions, and methods, defined by the proc, func, and method keywords, respectively. In some ways, NIM is a bit more pedantic in its definitions than other languages. And that's good. Have well-defined terms for things so that when, people who teach the language or talk about it, don't use things interchangeably. Therefore, communication is a little bit easier. Functions are closer to the concept of a pure mathematical function, which might be familiar to you if you've ever done functional programming. Essentially, there are procedures with additional limitations set on them. They can't access global state, except const, and can't produce side effects. Oh, so they can't access global state. That's awesome. That's a good limitation. And of course, can produce side effects. Great. The func keyword is basically an alias for proc tagged with no side effects. Functions can still change their mutable arguments, however, which are those marked as var, along with any ref objects. Unlike procedures, methods are dynamically dispatched. This sounds a bit complicated, but it is a concept closely related to inheritance and object-oriented programming. Oh, if you overload a procedure, two procedures with the same name but of different types or with different sets of arguments are said to be overloaded. The procedure to use is determined at compile time. Methods, on the other hand, depend on the objects that inherit from the root object. This is something that is covered much greater depth in the second part of the tutorial. So yes, that's why in CommonFS we're using methods, because we can have inheritance. Okay, so let's mark it that we finished before iterators. Just gonna write it down. Nem tut part 1. Iterators. That's what we need to start with during the next stream. But hey, we're like nearly halfway through the tutorial. Sure. Hey, we covered some of it many times already, just in different words. So let's get rid of the tutorial and let's get back to our code. Let's just take a peek at our plan. Because during last stream, we basically implemented, the previous stream, prior to the last stream, we define, create directory, check if directory exists, remove directory. During last stream, we implemented get file handle, create file, file exists, remove file. We even defined set current directory and get current directory. And then what we did is that we actually made sure that the set current directory and get current directory are already handled, so that if our file system has specified some kind of let me show you, because looking at the code will be a little bit easier, I think. So if we'll go into usage, okay, this would be a good example. We define some kind of directory path, all right, to our test directory. Then we create a file system, new OS file system, okay? This returns us just a generic file system. And then we can, check if the directory exists, do this or that. Then we have a file path, and we can do basically the same thing. But when we look at our test, because we have the tests directories and we have current directory test. So what happens here is that at some point we can do set current directory on the file system and give it some kind of path. So for every relative query done on that file system, like create directory, and we give it a relative path, it will be prepended with the current directory. So it's like, in a terminal, you have your working directory. So if you do cd hello, it will look for the directory hello inside the location that you're currently in. So this is the same thing here, but we don't want the create directory or directory exists or whatever other methods that we're defining. We don't want all the libraries to, because the idea is that you can make your own implementation of that interface, we don't want that implementation to really worry, oh, did they give me an absolute path? Did they give me a relative path? I need to normalize it now. I need to do this and that. Suddenly we would have that. So because of that, we just came up with an idea that, hey, for example, let's take the create directory as an example, right? So if we'll go to our interface and we have the create directory. So we made that this is just a proc. This isn't even, being implemented by the interface. It takes that, file system that we're operating on and the path. And already here, we are basically converting it to an absolute path. Our interface library, or whatever it is taking care of that, taking the absolute path and calling the actual implementation already with an absolute path. This way, the implementations that will be provided by different libraries won't have to worry about, oh, did I get relative? Did I get absolute? They always get an absolute path, as in a full path. So, that little complexity of handling the whole, what was it? The whole, oh, what is my current directory? Set current directory, get absolute path to, or whatever. They don't need to worry about that. They just get an absolute path and they just deal with this stuff. So, something simple. Easy for us to add. We have this explicit that, hey, this is create directory implementation. So if we go to our OSFS, here we have, the only thing we override is, hey, create directory implementation. We already get an absolute path and all those other things. So our implementations can stay simpler, can take away edge cases as we learn of further edge cases in our setup. We'll be able to probably shove it into CommonFS and not worry about it, because dealing with the path is a problem that's basically that will apply to no matter what backend is, no matter if we're dealing with a real file system in memory or FTP or something else. This is, this is just a thing with file systems. So we might as well take care of it here. So what should we do next? Well, last stream we started kind of dealing with testing, right? We define our test library regarding directories, and we have current directory tests. And I think it was supposed to be create directory tests. So let's rename it. That would be the first step. Create directory tests. Okay. Let's get rid of the binary. We don't need that here. We've create directory tests. So, whoa, twice. What the hell? So basically what we're doing here, we use the, what is it? Testament. That's the name of the testing library. And, we were able to pretend that we have some kind of setup. We have some kind of act where we do a bunch of things. I was, confused because there was no quick way of checking if an exception's been thrown. So we literally needed to implement try, except block to catch those errors. Same here. I don't know, it's kind of manual. I'm used to something like Jest in JavaScript where where I have nice helper methods for testing it. So I reached out on Discord to some other Nimmers, if that's the name of people who program in Nim. I'm not sure. And they told me that this whole library, you go here, documentation for the whole Nim language, and there will be tools documentation. And right here, the only tool regarding testing is Testament, right? Testament is an advanced automatic unit test runner for NIM tests. It's used for development of NIM itself. And turns out that people are saying, you know what, it's not the best idea to use that for your unit tests, because apparently it's targeted more towards checking if things compile properly rather than, running all those tests. So they pointed me that if we go to standard library, we should be able to find something like, I forgot the name, super test or something test? Unit test, there we go. There's miscellaneous. Unit test implements unit testing. There's just a library for that, okay? And you have a library. Instead of unit test, please consider using the testament tool. Yep, but still people are not recommending that. And you can, you can run your single test. You can get a whole suite or selecting tests by patterns. And, you have something more classic, like you have your suite, you have your setup, you have teardown and individual tests, right? This looks more familiar. We can give a test a name and whatnot. The only thing here is that you're expected to have one file with all this stuff. And you can run those files more of a, let's look. This thing can be used for globbing. So delimit the end of a suite name with this. So you do nim our test, you say something, and I don't know, does it find all the tests in your test? Because look, nim cr test. I guess we give it a test name and it finds it in all the files. If that was the case, then hell yeah. That would be nice. So, sure. So that's one thing. The unit test. But in addition to that, if we'll go to and search for nim unit test 2, there's a library on GitHub called unit test 2. Let's just go to the whole library. There we go. Introduction, unit test. It's a library for writing unit tests for your NIM programs in the spirit of XUnit. And it basically is pretty much the same thing. It's just an evolution of the unit test module. So that's it. You just install it through Nimble. And you use basically in the same way. You just need to remember to import it. And there you go. Right? But the thing is that you compile and run in your unit tests, but not with nim test. You need to use the, hey, compile and run in that specific file, which I don't like here. Compared to this one, where we could do, hey, run me a test with that name, or I guess run everything. Yeah, I guess if we will run that, we could run everything, all the tests. So that's the thing I don't like, okay? And yeah, I'm not sure what the actual difference is, because if we'll look at here, our examples show that you have suite, you have setup, teardown, and test. And there you have something like require, check, and expect. Okay? So let's just quickly look through that. You have some random types. We don't care about types. Procs. We have checkpoint. Okay? Checkpoint completes the report and closes the underlying stream. Don't care about that. But I believe the checkpoint is important. Set a checkpoint identified by message. Upon test failure, all checkpoints encountered so far are printed out. Right? So this makes sense. What else wasn't here that was important when I was looking through it? Macros. We have check. We have expect. Awesome. And we can force fail. We can use require. We can skip the test if something happens. And we can define a suite. Okay. And the test itself. So fairly simple. Nothing crazy here. Let me just check my audio works because I am not sure if you can all hear me. Simple. Yep, audio works. Okay, good. So we had those. Let's compare it here. Do we have some kind of documentation for it? We should have documentation, right? Documentation. There we go. Documentation. So. No. Oh. Specify the test names and it looks the same as the other one. Maybe we can actually run this thing the same way. That would be something to check, I guess. Because if it means that we can run it that way, hell yeah. What do we have here? We have the procs, all the same things. Methods, all the same things. All right. We have check, we have expect, checkpoint as a template instead here. Okay. Dual test. Dual test because you can define like tests that's run, I guess, for compilation and tests like build time, whatever. And then you have a test for runtime or both. You can fail or you can require. Yeah, runtime test. You can skip static test, exactly. Suite and test. And that's it. That's the only difference. So how about because if we'll go here, there is a thing about upgrading. Porting code from unit test. Replace the import unit test with import unit test 2. And unit test places each test in a separate proc, which changes the way templates inside tests are interpreted. Okay, and prepare the code for two-phase operation by reducing reliance on globals and test execution order. Great. So they actually had a separate procs. No, I guess behind the scenes it just does things up differently. So that's pretty much it. So how about we start and rewrite our thing to use the standard unit test. And then if that works, we can try to upgrade to unit test 2 and see if we can still run, like all the files with one command or something. Because I think that will be pretty cool. So let's see. Examples as you do all that. And I presume you use your import standard unit test first. So let's check that. Let's copy this. Okay. And let's do it here, okay? We have all our imports still. We just need to do import standard unit test, okay? And right now it's complaining that it's not being used, but we don't worry about it. So here we need to separate things into suites. So we'll have our suite, okay? And so let's do suite and let's call it sure, OSFS create directory. There we go. That's the suite that I want. And within that, we can have our echo suite setup run once before the test. Oh, I guess right here, we could write some code that will be just run once. I don't think we care about that right now. Then we have setup. And for setup, we could actually do the setup thing. Right now here we were doing it just once, but let's do setup and we can just move our code here. Let's just make it var test directory path. No, we can do it once, right? So let's do let test directory path is the same thing here because this won't be changing for our tests. The same thing goes for the file one, right? Where is it? Oh, we didn't do that here. Okay, so we have our test directory path. Okay. And then in our setup, we just need to create that directory. So we create it. It's funny that we're using the thing that we want to test. Oh, no. Create directory is straight from the system. Okay. From standard library. So we're not using our file system here. Good. So let's continue. So our setup, teardown. And our teardown will basically need to remove the directory. And what was the false for? I guess if we want to check something or whatever. Let's see here, cleanup. Yeah, exactly this. So we don't need those here, the cleanup and setup anymore, because that's taken care of here. And that will happen before and after every single test that we're going to define. And now we should be able to just go, oops. We should be able to go just straight up to each test. So let's check it out. Yeah, test something and do the things. Test something, do the thing. So I recall that this whole require thing is if you need to check some things that they actually work, if this doesn't succeed, basically the whole test is being just scrapped instantly. And I think it doesn't even call teardown for some reason. So I don't like that. I guess I'd prefer to use the require somewhere here before we even build something. Something to learn about, but I don't think we'll be using require here. It will be using the check. So let's go back and write our first test. So we'll do test, and it will be creating a directory using absolute path, right? And therefore, inside here, let me just change that. It keeps wanting to use 4 spaces, which just drives me nuts because it should be 2 for name as far as I know. So we'll need to fix that at some point. I'm sure there's a way to specify it for VS Code. We'll check it after we fix this test here. So we have our first test, okay? And our first test, let's also make it so, can we do this? Where fs, let's do var fs file system, okay? We'll specify it here, and we set it here, okay? So the fs will be ready for us every time we start the thing. So for the test, let's just cut that, paste it here. So we have our first directory, second directory, so that's that. And we create it with the absolute path. And instead of asserting, we should be doing the check. Let me just look for the check thingy. Check. It just takes condition, and that's it. Verify if a statement or a list of statements is true. A helpful error message and set checkpoints are printed out on failure. Okay. So basically, you can check, and you can check multiple things. Ooh, fancy. So you could do that, or the whole thing. Okay. So I guess this will be still a single check. Or not? No, because this is literally a already returns true or false. Same thing here. Okay. All right. Okay, too bad you can't provide any error, but it should be fine. So we just do check, and this should directory exists, and that should return a boolean. Okay, and that's our first test. That's it. Okay, so we should be able to do another test, creating a directory using a relative path. So let's actually rename some of those. We could just do directory relative, directory absolute here, and this way we have a little bit cleaner. The same thing will be here. This will be relative, while this will be absolute. Okay. So creating directory using relative path, we have this and that, and we set our current directory. Okay. And we create the directory and we do the check. Oh, the check is already here. Oh, the AI helped us. Okay, I see. I pressed tab without even thinking. So comparing those two, this looks good, this looks good. I guess it's gonna be all good. Test directory path. It is defined. So I don't know, it should work, I guess. We'll discover if it won't work. Then we'll be creating a path, creating using absolute path when current directory is set. So that's the thing where we'll need to modify some things. Because so far those tests were running where we were going one after another without clearing in between. So if we'll try to do this, creating using absolute path when current path is already set, no, this is still good. Okay, so we should probably be able to tab it. Relative, absolute, all looks the same, and we just set of absolute and check it. Great. This is where we have the error, right? Creating a directory when a file with the same name already exists. So we're expecting an exception, right? So this will be a little more interesting. So let's see what the AI will try to figure it out here, right? It specifies that we have that fourth directory and figure out the absolute one. Oh, no, it's okay. We create it, right? We create the directory. I mean, we create a file like that. And then we're basically trying to create it and check if it works. So as far as I know, I will look at the docs. We should have expect. There we go. Macro expect. Takes list of exceptions and a body. So test if body raises an exception found in the past exceptions. The test passes if the raised exception is part of the acceptable exceptions. Otherwise it fails. Okay, so we have a bunch of stuff, and basically we can do expect, what errors, and then what code. So we could have multiple instructions here that, we could, probably try multiple variants if we wanted. But okay, so expect, what errors, and bam. So let's try it. So instead of here we're expecting any kind of exception. Let's do expect, and we'll do a catchable error at this point and create a directory, right? Because it should throw an exception like, hey, this should fail. So we expect it. And that's it. And then we'll have the last one after that, which will be creating a directory when a directory with the same name already exists. So yeah, that's another thing that we need to basically cover. So let's think. See, this one already tries to reuse the path, but here we can probably cheat it a little bit. I mean, not cheat it, just do it normally. So we have another directory with we get the relative and absolute path. And basically what we're doing here is we create that directory. And when we create it again, we should expect catchable error. And the second time we call it, only then we should actually have an exception. If we get it earlier, that means there is something wrong. So that's that. And hey, that looks so much better, to be honest. So much better. This actually doesn't look that bad considering it's a test. I'm used to tests usually looking horrible. So, hey, I like it. All right. So, this isn't being used. So let's get rid of it. Right? We'll see. So how do we run it now? Let's look again. We'll start in the beginning. We can say nym compile run test and the name of the test or another test. I want the whole suite. So nym test and my test name and colon. Okay, the suite name. Sure. A single can be used for globbing. Delimit the end of a suite name with blah blah. Okay, I guess we could just do star bam bam and it works. But let's try the first one first, okay? Our suite is called this. So let's just copy this, okay? And we'll go here to our terminal. And we'll start with this. And instead of my test name will be osfs.create directory, right? And we have those two columns after that to say that, hey, we're just dealing with that. Okay. Important and not used directories. We just fixed that, so stop complaining. And let's try enter. Cannot open test.nym. Oh. Okay, so it expects us to just have the test.nym here. That's all it is. Boo. So I guess that will work if we would move this to tests. Okay, move it there. And rename it to, come on. How do you rename here? F2, test, right? So we go to cd tests and we have that test here. And now when we run this command, there we go. It worked. Cannot open the file. Oh, now because we can't open it. Why do we have 3? What's going on? Now we just need to fix those. Like this, because we just moved it from subdirectory to the main, to the parent. Let's run again. Undeclared identifier, FileSystem. Because we need to get FileSystem from CommonFS. Save and run again. Type mismatch. Oof. So what do we have here? We have a bunch of hints. And then we have here template generic instantiation of switch from here and test. I guess, just goes through them. They have error, type mismatch, expression create directory, test directory path. Expected one of the first mismatch at position, prop create directory, self file system, path, path. That's why we had the whole import standard directories. It's just, again, we trusted nym suggest and it led us some bad place. Okay, so what do we have here now that we run it? It did a lot of stuff here, right? I guess all the libraries that were chosen. So we have suite. OSFS create directory. Creating directory using absolute path worked. And then we have fail, the creating a directory using a relative path. Look at that, something's not working here. And then creating using absolute path with current directory set, with a file, the same one already exists, so that's good. And creating a directory when directory of the same name already exists. It just failed because I think when the directory already exists, it assumes that it should work fine. So that's something that we'll need to, make some decisions about how we actually want things to happen. So let's take a look at creating a directory using a relative path. What happened here? Creating a directory using relative path. We have our relative path. We have our absolute path, which is the test directory path, combined with this relative one. So we are setting current directory. Oh, what? It should be fs.set current directory. There you go. And then, because we're doing for the file, our file system, not the actual application, because I guess the set current directory was also available somewhere in theirs or probably paths. Okay, let's see if that fixed our issue. Yes, that fixed our issue. The only issue is that we're expecting an exception here. So basically, when we try to create a directory, when that directory already exists, with the same name. So this is the question. Should we throw an exception? Or should we just assume that it worked? Right? Because the end result is that we want that directory to exist. But at the same time, when we create it, and we just created it, we kind of expect that it should be empty, right? So I guess what we should do here is add an option to check if it already exists and throw if it actually exists. That could be something. So, So it'll be somewhere where, let's go to our OSFS, no, to our CommonFS. And we have our create directory, okay? So, creates the directory at a specified path. It does not raise an error if the directory already exists. So that was our first idea, and that's how actually the underlying create directory works, right? We go to OSFS, we have our create directory, and we just call it. It does not fail if the directory already exists, because for most usages, this does not indicate an error. And I think that'll be fine, right? Because nothing is stopping us from checking first. Does it exist first? Let's check. If not, not. So we should basically do it that this should pass normally, right? No problem. This should be our outcome. So something tells me those names here are wrong, because it'll be more like should or something of that sort. So let's just copy the whole thing, okay? Let's ask AI to give us better names for those. I'm just lazy. And as far as I know, AIs are usually good with unit testing and writing your test code and conventions and whatnot. the following code is written in the NIM programming language. Please make the test names more proper. Please correct the names of the tests so that they resemble, so they align with common testing, common test naming conventions in software engineering. Okay, because it should be a little bit more decent than what I had here. So nim, and we just pass it the file and run it. It should be relatively fast, right? Everything stays the same. I won't look at it. Okay, we go. Should create a directory using an absolute path. So while it's writing, we're just gonna go and copy and paste. So should, instead of creating a directory, should create a directory using an absolute path. Should create a directory using a relative path. Should create a directory using an absolute path when the current directory is set. Perfect. Very clear. Descriptive. Should throw an exception when create a directory with the same name as an existing file. Oops. And bam. And then we have last one, should not throw an exception when creating a directory that already exists. And that was so much faster than if I were to do it myself, just slowly. And left the suite name the same, so that's good. Hey, I am happy with that. We just tested, we just redid all the tests for this particular use case. It's just we need to run test names one by one, which sucks. But I have an idea about that. So let's just rerun it so that we can make sure we run the OSFS grid directory. And there we go. All of them passed. Nicely named, so you know that it should throw an exception when creating a directory with the same name and as an existing file. This way we can use the tests as, kind of documentation. So that's great. That's absolutely great. So let's commit that code, okay? Because we just made some changes. Unfortunately, when we run that thing, the test thing shows up here. So I guess we could specify another task or something that basically, it'd be just nice to have little shell scripts that we can run to do those specific things, like, hey, run tests, do that and that and that. And it puts everything in the bin rather than somewhere else. All right. Just give me a moment. Okay. So let's actually add that script quickly, okay? In theory, we could add tasks for VS Code, right? In theory, like run module or something, and it places it in the appropriate folder. How the hell did we use it? Run module name, run this, run that. I guess we weren't using it properly. We were just using the runner, which we already configured to place things here. Hey, let's use AI again, okay? Now I'm trying to configure VS Code so that it can run proper tasks for compilation of the project and testing the project. The compilation task is kind of complete. I'm just not sure if it's all correct. As for testing, I'd like the task to execute the following command. Okay. And we just, sure, this will be our file. Current, what is it? Tasks.json. Let's actually put .vs code / tasks.json. And we want our command to be something like this, where we can do nimc. It will be, I guess, tests / test. I guess. Let's do .nim. And it will be basically any kind of test. So, yeah. Oh, and we want to add the output. So let's do before or after R? Before R, okay. Whoops. Come on, paste in place. And this will be the test. Okay. Let's see if we get something usable. Because I never configured VS Code for anything decent. Great, let's update your task.json to file to include the tasks for running tests. Here's the updated version. So we have the build current file for debugging. We have our run module, and this will be the new thing. Nim run tests. Bam, bam, bam. And that should be it, I guess. Let's just copy the comma. Whoopsie. Gosh, the Claude has really bad interface. Things selecting weirdly. As the nice thing is that as you're typing things, you know, the markdown is actually showing up as actual markdown. But because the implementation of it is kind of wonky, I'd say worse than even in something like Notion, where it's not a great implementation. While compared to that in ChatGPT, it doesn't have any highlighting for whatever markdown you're sending. At least it doesn't get in your way with, you know, switching into HTML, not letting you do this and that. Ugh. Poor choice, I'd say. So let's go here and just shove it in here. Nim run tests. Now the question is, how do I actually run it? First of all, our terminal, let's just get back to our CommonFS. I don't know if that matters or not. Let's get rid of our build version here. Okay. So we've got that. Now what? A Ctrl-Shift-P, run tests. Nope. How can I run those tasks? the save updated file. How can I run that task in VS Code now? How do I do that? Like for correct and compose the current file. These blah blah. Okay. So Control-Shift-P, type run task, and select it from the list. Oh. Then you can also use keyboard shortcut to run tasks quickly. Windows, do Control-Shift-B to run the default build task. Oh, the default, okay. Since you have set is default true for the nim run tests task within the group, it will run the tests. We did? Is default true? Well, this is default true and this one isn't. Okay, for the kind test. Within the group kind test section, pressing the Control-Shift-B will trigger the nim run test tasks. Really? Control-Shift-B. Control-Shift-B. No, that's not it. Okay, so let's do it normally. Control-Shift-P, run tasks. Okay, tasks, run task, or run test task. Click. Oh, it worked. Okay, so can I just do Control-Shift-Test, enter, and it goes. Okay, that's gonna be handy. So now we have it running. It doesn't build the thingy here. It just goes to somewhere like, where is it? It's being built inside the bin. Okay. We have test directories here and there's some directories here. What if I'm gonna remove this thing? Because I don't want this thing to show up here ever. And let's do again. Test. Okay. And didn't create anything here. Everything's only here in temp. Perfect. So let's go to .gitignore and let's remove that temp. Save. So we don't want to commit the temp nor the bin. So let's go to our what do you call it? Well, let's launch our Git client. Wait for it to start up. And come on, full screen large. Okay, so what changes do we have here? We have our temp added. We expanded our tasks. We have our CommonFS as discardable, sure. Quick fun, we will just skip for now. Test results, pattern JSON. Oh, we don't want any test results folder, right? Delete it. And delete it. There we go. That's better. That's probably from the other one. So current directory tests, we get rid of it here. We have just overall tests. Bam. So we can call it re-implement tests using standard slash, what was it? Unit test. Okay. Let's push it. There we go. So those changes applied, but now I'd like to have it somewhere else. I'd like the test to be regarding directories. So I have an idea. what if I'm gonna grab this whole thing, okay, cut it out of here, go to test directories, create a new file, and call it create directory tests.nym, and just paste it here, okay? We have OSFS create directory. Everything will work. We'll just need to correct our imports, okay? And that should be it. So in our tests, so far we're doing import something. But we should be able to do include directories / create directory tests.nym. So let's just fix that name here. Okay, and we have our test here. And what's gonna happen if I'm gonna try to run the test? Warning, import paths is deprecated. Oh, let's remove dot and let's run it again. Still can't open file directories, create directory test. Dot slash. Let's try it once more. No, nothing works. Cannot open file directories. Directories. Right. Directories. Create directory tests. Directory tests. There we go. Let's run it now. And it worked. Great. So that means that the include literally copied this file into this one here, right? During compilation, just copied the whole thing, shoved it in here, and we're done. So what if, just for kicks, I'm gonna copy the whole file. Let's rename it to Wallalaw, okay? We'll have what is going on with all that? Save, go to settings, and remove this whole licensing string because it drives me nuts. So we have our Wallalaw. And it has the same import, so it kind of tries to import the stuff again. We just make it OSFS Wallalaw, just to have a different suite name. The rest should be the same. You know, it won't hurt if we test something twice. And in our test, we just include, and instead of that, we should have Wallalaw. Okay. Let's try to run it now and see if those imports don't like each other. Hey, it worked. So that's how we can solve our problem of trying to run multiple tests. Well, we can just include the files with those tests. Okay. I like it. So let's get rid of that. And let's see, do we need this period slash? Can we just do without it? Yes, we can. Okay, sure. Our problems are solved. So that'll be another comment. There we go. Settings. Remove annoying licensing string VS Code feature thing. Okay. And we just make that. We don't want the Wallalaw, we just want to delete the file. Doesn't matter anymore. And our test name will just have the include. And we make it and I mean utilize whatever. Organize tests. Sure. First step, there's only one test to organize, so it wasn't much work, but hey, at least we have a structure to follow, right? So we push it, and hey, we've made some progress. I'm very happy about that. So I'm gonna take a short break, and I'll be back probably in 2 or 3 minutes. All right, I'm back. So what next? We tested basic functionality of our, where was it? I mean, CommonFS, create directory, okay? And the thing is that we shouldn't even worry about giving relative path or absolute path, because in this test here, I can't double, jeez. VS Code sucks. Absolutely sucks. So basically, here we kind of test the OSFS, if it works, right? But at the same time, these tests should be able to run pretty much any kind of library. Doesn't matter if this or that. All the tests should be actually for all of them. Should I like export the whole separate package that implements the tests? You only pass the whole thing a proper method to create the file system, and then whatever inherits, I mean, tries to implement the CommonFS can just do test and run that specific file with that specific value or whatever, just pass the closure for creating a file system. I don't know, crazy to think about, but imagine, it'd be very interesting. Why is it saying that the audio stream bitrate is 0? Now, YouTube is so weird with streams, complaining about non-existing problems at all times. Ay. Okay, So let's continue. So basically the idea would be to specify those tests, but instead of just in a setup create the file system new OS file system, we would just need to provide method that just returns the file system, and then whatever needs to happen just creates those tests. But how would you import that? I'll need to ask around that about something like that, because this is an interesting concept that our library, the CommonFS, would basically specify all the tests that are required for basic, basic operations. But yeah, for that, and would test all the implementations to make sure that all the implementations exist. Okay. And then basically the implementations can pass its own constructor and go for it. Test it that way. So implementation of the specific implementation won't even need to write any main tests. All it will be able to do is, write its own tests for its own little subcomponents, just to make sure that during development everything works. So yeah, this is pretty interesting idea, at least. But for now, let's just continue with testing our specific parts of the CommonFS. So I'd say before we continue with checking the directory operations, okay, let's do the basic files current directory operations. And let's make sure that those implementations are valid at all times. So in our tests, let's create a new folder called current directory or something. And here, new file. And let's do it set current directory. Or let's just something like current directory tests. .nym. Well, let's do that. All right. Let's just have a decent. Again, this got created even though I updated the settings to not create that. Go figure. Oh, I know. I probably have it somewhere in settings from at some point where I was setting things up. Oh, I know. nym or something. License string. Nope. Nothing here. I don't know. Maybe when I restore the VS Code, it will notice that settings have changed. Alrighty, so let's get our tests here on the side. Okay. So we basically need to import this. We'll be dealing with paths, so let's do that. And we'll need our file system, okay. And I guess OSFS at this point. And we do suite, and let's do OSFS dot current directory, okay. And our first let's do, of course, we'll have our file system, and then she'll be creating it during our setup. Again, let's ask AI how can I force VS Code to use 2 space indents for my project? Okay, settings, no thinking in the settings. I don't want to go through the settings. Specific for a NIM project, you can create a project-specific settings. VS Code folder, settings.json, and a settings.json file, add the following configuration. NIM, editor tab size 2. There we go. Settings. And we just do straight up this. Okay. And let's close it. Let's start again. And maybe this time it will finally start respecting something. Okay. We can do this whole. Okay, sure. Whatever. The current test NIM. Why not 2? Default tab is 2. Okay, I guess for that file, it just detected it. Ay. So we have our new file system. For teardown, we don't need to do anything, I guess. And how can we test our current thingy? Let's go to the right and let's open the CommonFS NIM. And let's check it out. Let's actually rename it, not OSFS. Let's make it straight up CommonFS. Or no, let's do OSFS because we need the implementation. And no, we actually should have it file system as new file system, okay? Because this way we don't have anything implemented, no implementations, but that shouldn't stop us from using those. And that should be another requirement of the test, that it should be independent. Okay, CommonFS, current directory, perfect. So let's get rid of OSFS, we won't be using it here. ROM, what? ROM, okay, now it's better. So current directory returns the current working directory. The working directory is always an absolute path. Okay. So test should be an absolute direct also path by default. Okay. And can we actually do this whole is absolute? We won't be using asserts, but sure. So let's again take a peek at documentation. Let's again duplicate this and we'll go to, where is it? Here, standard library. And now recall that we had the OS paths. Do we have something like is absolute? Add is absolute. And it will just return true or false. That should work as in a standard library, so that should be correct. So we want to check instead of assert. So should be an absolute path by default. So even though we have fresh, brand new file system, it should be straight up, absolute path. Test should be an absolute path after changing. So fs current directory is test. Okay, after changing via relative path. Okay. test here. Okay, it should still be absolute. Then it should be an absolute path after changing via absolute path. So if we're gonna give it like an absolute path, it should still work. Okay. After changing via relative path with dot dot, that shouldn't be a concern here. I guess that's it. The only thing is that we can't really check it like that. So let's see, how can we set it? We set it with set current directory. Okay. So it'll be set current directory and set current directory here. Although I just remembered that we could actually allow something where we define an operator for assigning to the current directory. Then that was a good idea, because we could, in theory, do proc to current directory equals, all right, and then we basically do the same thing. All we need to do is return self.set current directory, right? And specify the same path. We just did the same thing as here. And we are not returning anything in the first place, okay? Yeah, I should be able to do that. The only thing is that it should go in the other order. So let's do it this way. We're gonna have this here, while this will be basically self current directory is path. Something of that sort. Okay, and yeah, right now we have two things, so they both should work. So let's actually do current directory is this. And this thing here. Current directory is bam. So they both should work, okay? Let's just quickly go to our, I can go Control P, right? Test name. And let's just include that test here. So it'll be, what was the name of the directory? Current directory. And we do current directory tests. Okay, let's save it and let's try to run our tests. Errors. Undeclared field current directory for type CommonFS file system. Huh. How so? CommonFS 3.4. CommonFS 3.4. What? Current directory test 1713. Okay. 1713. 1713. So there is no getter for it? That's what they're trying to say? There's a proc. Oh, I guess I will need to do this, right? I presume. Will that work? Save it. Run it. Tempting to call undeclared routine current directory. What is going on? Why is it saying that this is not defined? Oh, because I'm not importing it? Current directory. Save. Run again. Set current directory. Oh, of course. Come on, set current directory. And let's run it yet again. Okay, type mismatch. Test here string. Expected one of the first match. So the current directory, FileSystem, a path. So let's see, where am I making the mistake? fs set current directory, and we give the name. Oh, right, dot path. That's true. These all need to be paths. Look how many mistakes I'm making. And declare field current directory equals. Oh, so I literally need to import that as well. Current directory equals. Or do I need to do it in backticks? Yes, I need to do it in backticks, I guess. Set current directory equals for type CommonFS 2622. Let's take a peek. 2622. Oh, I'm doing set current directory and equals, which is wrong, of course. This we're just calling the method. Run again, and finally, we kind of worked. Should be absolute path after changing via relative path. That didn't work. That's interesting. So we'll need to fix that. Okay. So what I'm seeing here is something that I don't like. When we have current directory, we need to call it like this, right? Let me double check if we actually have to, or we can just skip the whole thing. Run. Oh, we can skip the whole thing. So if we have a proc that is just called on this thing, we can just do dot after that immediately. We can treat it as a simple field. So that's good. And that means that this should work as well, right? fs current directory, we just provide this here, and we can get rid of the set current directory completely. All right. And we have just like that. Setter and getter. And that should be it. So let's run those again. And should be an absolute path by default is false. So what is the current directory by default? That's the question. Okay, so we're writing tests and we're already getting some, proper mistakes that we didn't consider first. It's like, initially when we get the current directory, we return the current absolute directory. And current absolute directory is just nothing initially. So let's make it just this, okay? Dot path. I hope this works. And when we run that, everything should work. Oh, no. Should be an absolute path by default. I guess it's not. So what is it by default? Can I do echo by default current directory is this? Will that work here? Or will it be just, hidden away or something? Doesn't show it. But I think we can do something like checkpoint. And we just do ampersand. We just concatenate this string in there. We save it and run it, and we should see it displayed. Oh, nope. We need to do the dot string. Okay. And now we should have it printed. By default, current directory is, and it shows nothing, absolutely nothing. So, did we give it default path? Oh, we did default path of the file as that current absolute directory. There we go, nothing. Run again. Oh, now everything works. Okay, so we just need a reasonable default for things to work properly. Okay, good. Hey, we just tested the getting and assigning the path. Okay, kind of. Because we're checking if the absolute path is basically set by default to an absolute path. We check what's an outcome if we're gonna add a relative or replace with an absolute path, if things are correct. And we should also check that if we added the absolute path, I mean the relative path, we have this. Let's actually replace that here. We check here when we set the absolute path that we have the proper, what do you call it? That we have a proper directory, that proper thing set. But for setting the relative path, we can also check it that, you know, initially is that, but we can add another one where we, you know, kind of append another one, and suddenly we can check if it's still absolute, and we can check if it's test here slash test slash here. We can actually do dot slash, okay, and it should be test here, hopefully. And this way we're gonna check if it actually the assignment works properly. Okay, let's run it, and we'll have those tests, they pass properly. Cool. So we'll do, you know, I mean, this, I think it's self-explanatory, so that's good. So we're setting it, reading it, and that will be it for the current directory. The only other thing is that we would also need to test the, let's actually remove the set current directory. We're gonna fix our things shortly. Get absolute path 2. That's another thing that we need to test properly. So, yeah. So let's create another test file. It will be get absolute path to tests. Not sure if that needs to be in a separate file. Let's not do that. Let's not overcomplicate it. Delete current directory tests. This is regarding the whole thing. So let's just add another suite here. Okay. CommonFS dot, this will be get absolute path 2. Okay. And we have the same setup. Sure, whatever. The first test should be basically, what do we do with it? The get absolute path 2. So this returns the absolute path to the provided path. Okay. If the provided path is already absolute, it is returned as is. Okay. So this should be using the current directory of the file system, because that's what we're operating on. And basically, you know, it should either combine those two or return, you know, normal thing. And if there's something wrong with the path, we should get the exception. Okay, the invalid path error, because that's another thing that we should consider getting, and we should also consider testing it when we're setting the current directory. Okay, that's another thing to check. Cool. So we can do actually in the previous one, in the current when setting current directory, we should do a test. Should raise an error when trying to set an invalid path. Okay. So we basically expect, and it should be invalid path error. And it will be when we set the thing to be something wonky. But now what is something wrong here? The dot slash the dot slash the dot. Is that wrong? I guess we'll need to run some tests to figure that out. I don't know. I'm not sure what the wrong path would be here. And we do dot path. Okay. So run it. Set current directory. Oh, now we need to quickly, because I removed the whole set current directory here, and that means that we can't use it somewhere. Where was the problem? And current directory tests. Set current directory. Oh, of course. Set current directory. Gone. Run the test. Invalid path error. Okay, so you know what? Let's just import the CommonFS instead of playing with all that. Save and run. Okay, set the current directory. Create directory tests nim. Oh, there we go. Here we can have the set current directory. Set current directory, is that only one? So first of all will be import this thing, okay? That's one. Second, we have set current directory. I have only one, so be current directory equals, and we have this thing. Save. Now we should be able to run it. Yes, now we can run it. It's just last error. Should okay, here. Should raise an error when trying to set an invalid path. That didn't work. So we need to figure out what is the wrong path here. Nothing comes to my mind right now. What would be a wrong yeah, sure. Let's ask AI as we always do. What are invalid characters in the Linux file name? The / is used as their, okay, whatever. Null character. I guess we could try that. Some other control characters. 1 to 31. Okay. A colon is best to avoid it, but I guess it wouldn't be a problem. Asterisk. Just avoid it. Question mark. Pipe symbol. Angle brackets. Let's try them all. Let's do something like this. And maybe 0. But no, that's gonna break the string. It shouldn't, right? And then we do / and pipe. Double pipe. Save it and run it. Nope, it just, the path is always valid. Don't know how to get an invalid path, to be honest. Empty one should be still working, right? Everything works. It doesn't want to throw in exceptions. Let's ignore that. We know that the path itself will be doing that, so we don't have to worry. We don't have a way to test it, to be honest. Okay, so we just wasted some time. Oh well, happens. Alrighty, so let's just keep going. So we wanted to figure out how to test the get absolute path to. So this should be basically, yeah, we're testing this thing here, so it shouldn't be problematic. Just write few tests. Should return current directory if path is empty, right? Just something simple. So we'll do fs.get absolute path to, and let's actually do let path get absolute path to nothing. We can check if the path is absolute and check if it's the same as current directory. That should be one thing. Sure, return current directory if it's just that. Sure, it won't hurt to have a few of those. And the same thing here. Wow, we're testing a lot here. Okay. Should return the path is ... No, it shouldn't. So let's stop testing those silly things. Should return absolute path. Path is relative, so we add test here. So it should return test here. But what I'd like to do is actually, during the setup, I want the fs dot current directory. I want to add the test to it. So I want them to, these should be all same, right? But when I add relative like test here, I want it to be test here. And should return, what the hell? Why that will be? Because I had it here, because I had it somewhere else. Okay, it should return absolute path if path is absolute. So we'll just do that, and we have hello there. Should be exactly hello there. Okay. Let's run those tests and see if everything is still working. Something clearly isn't. Still tries to raise an error when trying to set an invalid path. What? Where? Why? Save. Run again. Oh, we have type mismatch. 4018. 4018. Oh, silly me. Dot path everywhere. There we go. There we go. Ay. Let's run it again. Okay, now everything works. Lovely. Okay, let's just clear it. Good. So, yeah. Okay, so if the path is absolute, it should add it. If it's relative, it should do that too. And we can actually do it twice to be test here. Okay, just recheck it. Oops. Oh. Um. Let's do it bar. Okay. This should fix the problem. Oops, should return absolute path if path is relative. Something's not going well here. Oh, right, because we should actually we can't do that. Yeah, we can't call it twice, because if we call it twice, it wouldn't edit it. So I guess we could do another test. Should not modify. Current directory. So we just do something and check if fs current directory is still just test, okay? And not test here. Universal path 2 is of type path, okay. As always. No, this is, oh, okay. Discard, let's discard the return value. Okay. I think we tested that little thing enough. So if all those three tested, which is awesome because we can rely on them. We don't have to wonder, oh, did I miss something? We have it tested. So next part will be basically to test all those. Create directory. And this and that. So, you know, kind of a lot of work, but shouldn't be that bad. The nice thing about it is that as we're working with it, we're basically learning how to use the library and seeing how it's being used, if it makes sense or if it absolutely sucks. So, you know, that's a nice thing, I guess. So now I'm just wondering, should we test those where we have like a decision to make? Should I test this and that separately? Because this here on its own should simply, what would you call it? You know, should just guarantee to get absolute path to this thing. But at the same time, how on earth do we test it? Because then what? I create new separate type that overrides the specific implementation to just test it. Gosh, that would be a lot of repetitive tests. That would really suck. Let's just test them as they go. As, you know, normal person would test them with relative path, with that path, because, you know, all we care about is that the whole thing works. We don't care if, you know, if something in between goes away. If we will at some point decide that, you know what, we're not having this here, we're doing something yet different about it, then we suddenly need to change all the tests. Let's just focus on the whole thing working properly. Okay. Oh, I have those single. Yeah, let's keep them single. Okay. All right. So because of that, if we will go to our Lovely test number 1, create directory test. We already test all those things, like absolute paths and relatives paths and throwing errors for the create directory for the main thing. So we don't, let's continue with it and do test if directory exists. I really don't feel like testing it right now, but I guess I have to. So let's create a new file in our directories. New file. Directory exists. Tests. Okay. Of course, we need to manually write its name. Copyright crept in from somewhere still. Oh, now I know. Settings. Nim. Now I will see it somewhere. Optional license. Oh, modified from remote. Go away. Okay, there we go. Gone. Okay. So, I guess we'll be doing something very similar to create directory tests. We get the unit tests, we need paths and directories, CommonFS, and new OSFS. New OSFS, yeah. We have suite OSFS dot directory exists. Okay. And we need to get the test directory path set up and turned on. Let's have it the same way. And this will be directory exists test. So just in case if things run parallel at some point in the future, we'll be able to differentiate them a little bit more. We have our FileSystem. We set up by creating the test directory path and then removing it. Okay, that sounds good. So now, yeah, there exists. Returns true for an existing directory. Okay. So let's do something like fs.create directory. And dir1.path. Okay. And we'll just have it check fs.directory exists. And we should provide it with we have this thing here. Let's yeah, because we need to respect with the whole of yeah. So I guess we need to do let director relative is directory 1 path. Let directory absolute is this. That's correct. And now we can basically create the whole thing as the directory absolute when checking for absolute path. Okay. So create directory absolute, and then we can check exists, and we can just give it directory absolute, and that should be true, right? That should already return us true. So that's that. Then we have returns true if existing directory when checking for relative path. So we'll just make directory 2 just in case they don't, so that they don't disagree. We again create the thing, but we use the relative path. But for relative path, we first need to do fs dot, wait, relative path. Oh, no. So, sure. So we need to basically do fs dot current directory is test directory path. And therefore now we can use the relative one. Okay. And should set true. So it should return false for non-existent directory when checking for absolute path. So we basically have the same thing. We just, the same thing as here. Not fs directory. Involved indentation. I guess if we have not, we need to do this, right? I presume. So next we have for when using relative path. Current directory is test directory path, and we should still have it not existing. Do I need that? I guess I shouldn't need that, I presume. Okay. So that will be it. And do we have any situations where we could get an exception when checking for existing directory? Not really, because we're only checking if it's directory. But we need to cover a situation where the thing we're pointing at is a file instead of directory, you know? Let's just run those tests and see what, oh, we need to attach them to our test nym. So besides that, we'll have the directory exists tests, okay? Now when we run our tests, error, undeclared identifier, except exclamation mark. Yeah, wrong programming language, I guess. So instead of those, we do not. Okay, we'll run it again. And now everything passed, so everything's good so far. So let's just do test there exists. Oh, I mean, we don't need there exists everywhere. Just returns, or like should return, right? That'll be better. Should return. So should return false for file when checking for absolute path. So we just have relative will be, let's call it directory 5 the slash file.txt, okay? And we need to do fs.create directory. And we do directory 5 dot path, I guess. I guess we could just do fs dot current directory is test directory path. We create that extra directory, and then we need to do the whole funny thing with creating a file, right? There we go. So file absolute dot string, right, close, okay. This will basically create the file, and then we can do our check. Not fs there exists file absolute. So if we give it this whole path, it should be unhappy. Okay, that's good. Let's run it. Let's see what happens. Yep, worked. Should return false for file when checking for absolute path. But let's just double check that the file exists. Check fs.file exists, and we give it the file just in case, okay? We'll in theory run the other thing that we shouldn't, but there's nothing stopping from tests to, you know, use various parts of the whole thing. It doesn't need to focus only on testing this one part of the whole system. It can use, like, you know, when testing the directory exists, we shouldn't be afraid of using file exists. Because, you know, sure, when we have file exists, we might test for directory exists. They will test each other. If there's something wrong with this, all the tests for that thing will fail, and additionally something here. So, you know, there will be enough of things pointing at what went wrong, and, you know, we can assume that all these work because they're being tested anyway. Okay, so we just tested the, you know, yet another thing. So let's commit it. Let's see what we have changed here. We added a tab size, so let's do set default tab size to 2 spaces as recommended by official, what do you call it, style guide. I read some of it. And now, CommonFS. Yeah. So we did change a few things here. So let's make it so that instead of having set current, we have the other thing. So in create directory, we just needed to change a few things. And I guess that was it. So this is basically replace set current directory with a setter of current directory. Okay. Then what we did is make sure default absolute path for FS is I have root path, okay, because we needed to ensure that. And then we have the test current directory related FileSystem procs. And then we have directory exists tests. Okay, so implement, how do we call it? Test there exists whatever method. Okay, push it. I just wanted, before we finish, because I think we should be finishing now, let me just take a gander at our CommonFS nym and see which of those need to be procs and which could be functions. Because if we would have things as functions, suddenly we could ensure that there are no side effects, which is, you know, an extra nice thing. So current directory just returns the current working directory, does not do anything else. So do we need for it to be proc? It's being compiled as no side effects because the compiler just figures that out. Okay, but if we'll make func, it's not that the compiler deduces that. Now we're actually making sure our code doesn't have any side effects. Okay? So that's like extra safe. Current directory set. Well, we're setting something here, so this cannot be func. Get absolute path. And this is another place where we should have it as a func, because we're just returning a new value. We're not editing anything. So, another little thing. Then what? Create directory. That will have side effects. Checking if directory exists. I don't think this will be no side effects. I mean, it shows us no side effects. Implementation here shows us no side effects. But before we do that, let me run our tests, okay? Because they're already using those functions. Everything is fine. But what happens if I'm gonna do this directory as func? Save. Run it. Hey, it's fine. How is it possible? It's calling a method that doesn't have to be no side effects. Unless our implementation of it actually is no side effects. Directory exists. It doesn't show that it's no side effects, okay? Because we're calling directory exists. Can I specify no side effects? What's gonna happen now if I'm gonna run tests? Now it's no side effect. Was it capital or something? Side effect. Second time I'm making that mistake. Effect. There exists implement can have side effects. So we can't do that, That is very interesting that you can kind of break the, we say that directory exists is a func. So I guess here, and only here, there should be no side effects. In theory, it should also check if this has any side effects, but this current implementation doesn't have side effects, while whatever is going to override it can have side effects. So kind of wonky. I'll return it to proc for now, because we don't want to suggest that, oh, it can't have an IO or whatever. So basically all of those, checking, getting file handle where we're, getting a file. Is CommonFS file? No, we just, okay, so this should be function because we're not modifying anything, okay? Get file handle. We just return a new thing with a path in it, and that's it. So at least that's good. But creating file, checking if file exists, removing them, all that, needs to, it can't be, what do we call it? It can have side effects, so we can make it into procs. So okay, we marked a few things as if functions. Let's run everything. Everything still runs, compiles, so that's good. All right. Yeah, I'm happy with the results so far. So let's just add another commit or whatever. I don't know how to pronounce that thing, where just those three procs turned into functions. Okay, mark some procs or turn some procs into functions to enforce lack of side effects. Okay, we're just enforcing it to make sure nothing's gonna get changed, because if, let's say, somebody commits to the repository to, let's say, help out and implement some additional tests, if I would see that, hey, this func turned into proc, this is suddenly an alarm. Hey, what is going on here? So yeah, that's fun. I like that, you know, you can easily add additional constraints on yourself while still having the vast flexibility of the language. So yeah, that was fun. And I'll be finishing for today, so thank you for watching, and I'll see you on Wednesday. And remember, like, subscribe, follow on Twitch, and you can easily comment after the stream finished. I'll be always happy to answer any questions. So, see you.